In this training, we analyze the curing of composite profiles during the pultrusion process using Abaqus. We go through 2 workshops step by step, first an eye-shaped section and then a tube-shaped section. All related theory and formulations are explained using the Chile model. To implement these models in Abaqus, various subroutines are used and reviewed block by block. In this training package, we start with an introduction to the pultrusion process, what it is, its advantages over other curing methods, and where pultruded profiles are used. Then, we explain the thermo-chemo-mechanical simulation of curing, why a coupled model is needed, and what relations are applied. Next, we show how to calculate non-mechanical strain and stress during pultrusion, using a linear hardening elastic model. We also describe the modeling process in Abaqus and the subroutines required, including film, UMAT, het-val, UExpan, and USDFLD, explaining their role and purpose. Finally, before starting the workshops, we review the overall simulation workflow. After completing the lessons, we move on to the workshops. To do so, the Fortran code of all the mentioned subroutines is gathered into a single file and explained in detail, block by block, and sometimes line by line. The same code is used for both workshops, and the file is included in the training package. In the first workshop, we analyze the curing process in an eye-shaped composite section. Since the specific heat in such cases can depend on both temperature and degree of cure, we developed an Abaqus Python script. With this script, you can define specific heat as a function of temperature and degree of cure, and the material property will be automatically imported into Abaqus as a table. Using the coupled temperature displacement solver in Abaqus, which is essentially a static solver, the analysis is carried out. Stress contours, degree of cure, displacement, and the cure time curve at a specific. In the second workshop, we demonstrate that with the same Abaqus model and code, you can easily analyze pultrusion for other types of sections. As an example, we study the curing process in a tube. Finally, just like in the first workshop, stress, displacement, degree of cure, and temperature are extracted as outputs. If you'd like more details about this training package, just follow the link in the description. The package includes over 100 minutes of training videos, along with all the Abaqus model files, Fortran code, and Python scripts used in the workshop.